Hello, beautiful people, and welcome. Today we're going to be going over your Module 18 quiz. Now, I did originally record one of these for the Module 18 quiz. I'm going to go ahead and replace it with this video. I want to go a little bit more in depth of how to do every single question on your Module 18 quiz. Now, this video is for Integrated Math 3. But it can be helpful for pre-calculus and it can be helpful for IM2 since we are talking about trig. We're talking about reference angles, coterminal angles, finding exact value or evaluating each trigonometric function. We're going to be talking a little bit about the unit circle, specifically quadrant 1 of the unit circle. If you're interested in that, go ahead and keep watching. Before we continue, I would like to take a moment and show you our wonderful website. So let me go ahead and do that now. So if you head over to teachingsylvanas.com, you're going to have the option of going directly to YouTube to find all of the videos. You have an option of meeting Sylvanas. So if you click here on Meet Sylvanas, it will take you directly to her YouTube channel. And then you can see all of the wonderful, cute pictures of Sylvanas. And then you can also watch recorded videos of her being just adorable. Let's go ahead and go back to our home page or home screen here. Since this is an Integrated Math 3 video, I'm going to click on Integrated Math 3. And here you're going to have all of the recorded videos for you. Semester 1, also Semester 2. Now, like I said earlier, some of these videos can be useful for pre-calculus and can be useful for Integrated Math 2. This is not strictly for Integrated Math 3. Algebra 2 is in here, trigonometry, logarithms. So all of that material is fluid throughout the classes. So if you have a friend that is in need of some review videos, definitely tell them to make their way over to teachingsylvanas.com. All right, let's go ahead and get started with today's lesson. Let's see if I can do this in one fluid motion, and I can. Yay, victory. Dance for me. All right, so Module 18 quiz, how to. So the first thing I want to go over is literally how to do each and every single problem on the quiz, but I don't want to do it for you. I want to give you the tools of how to approach each single question. So I have the quiz here, Module 18 quiz, and I want to kind of go through each question. So if you are in my class, you should have your Module 18 quiz in front of you when you're watching this video. That way you can make corrections, identify your mistakes. That way you don't make those same mistakes again. So the first thing I want to talk to you is finding coterminal angles. Now, coterminal angles are angles that start and stop in the same location. Okay, what that means is if you have an angle, let's say of 120 degrees, you're going to always start on this section here. I'm going to take a highlighter just so you know. This is called your initial side or your initial ray. Okay, initial side or initial ray. Let's label that. In my class, we call this the initial ray. On the other side, where you end up, this part right here, that is your terminal side or your terminal ray. So whenever you're drawing your angle, you're going to go from your initial ray to your terminal ray. And then here we're going to mark this off as 120 degrees for our example. Okay. So when it's asking you for a coterminal angle, it means it shares its terminal ray. It always has to start here, so it doesn't technically matter that where it starts because it's always going to start here. It always starts with the initial ray, positive x ray here. So it just matters where it stops. So to find a coterminal ray, we're going to, let's say, let me find a different color so it can be different. don't know if you guys can hear that, but there's a plane flying up above. Okay, so coterminal means it doesn't matter how many rotations or revolutions or how many cycles I do, I just stop at the same place as my original angle. I'm going to repeat that. So it doesn't matter how many periods, how many rotations, how many, you'll hear it say revolutions, how many cycles I go through, I'm always going to end at the same spot as my original angle. That is what coterminal is. So as our example, so our is example 1. So given angle was 120 degrees. Coterminal, what did we do? We did one period, which is 360 degrees, and then I went 120 more. So I did 360 degrees, which is one cycle, so one circle. So I did one revolution or one period, and then I did 120 more. Let me lower that down just a little bit. So what is my, I keep doing that. What is my reference, what is my coterminal angle? Well, my coterminal angle is just 360 plus 120. So that's going to be what, 480 degrees. So when a question is asking you to find the coterminal angle, you're finding an angle that shares the terminal ray. So here's now where I come in with your little thinking bubbles, cheat sheets, suggestions, ways to remember things. Okay, so if you're finding coterminal angles, you're going to add or subtract 360 degrees or 2 pi. So if they give you an angle that is in degrees, you're going to add or subtract 2 pi. If they give you an angle that is in radians, then you're going to add or subtract 2 pi. Okay. That's coterminal angles. So I'm looking at your unit quiz, and it says number 1 coterminal angle, number 2 coterminal angle, number 3 is asking to convert each radian measure to degrees. So let's go over that. So let's shift this up. So now we're saying converting angle measures and I'm actually going to combine it. So we're going to convert angle measures to degrees and degrees to, converting angle measures to degrees and degrees to radians. Making sure that that makes sense. Okay, so I'm going to start off by sketching out part of a unicircle. There it is. Okay, so we know that one revolution, one cycle, one period is 360 degrees, also known as 2 pi. We also know that half of a revolution, or half of a cycle, half of a period is pi, or 180 degrees. These right here are going to be your conversion rates. So instead of using the bigger numbers, 360 versus 2 pi, we're going to use this one here. This is going to be our conversion rate. So conversion. This is going to be pi over 180, your ratio, or 180 versus pi. So keep in mind that 180 is in degrees pi is in radians. So if you are trying to convert from a degree to a radian, you want radians on top. If you want to convert radians to degrees, you want degrees on top. So whatever unit of measure you want at the end, that is what you put on top for your conversion. Do an example. Okay, let's do something. Since we didn't have a calculator, and we will not have a calculator on this section of the quiz and the test, I'm going to choose pretty numbers. So let's say we have, oh, I don't know. Let's do 120. I guess 120 is my number for this video, 120. And we're going to try to convert 120 degrees to radians. So starting out with degrees, I want radians. So if I want radians, I'm going to choose the one with the radians on top. So I'm going to choose pi. And then I'm going to do 180. Since you do not have a calculator, anything that ends with a 0, you get to cross out or divide by 10. So then we have 12 pi over 18. Now I know 12 and 18 can simplify, so go ahead and do that. What goes into 12? That also goes into 18. And that is, what is that? I think it's 6. 6 goes into 12 2 times. 6 goes into 18 3 times. So your 120 degrees is 2 pi thirds. Let's try an example number 2. Go the other way. If we want something in degrees, we want to put degrees on top. So we want to get rid of our radians. So let's do, I don't know, let's do something like 3 pi. And we want this in degrees, so I'm going to say 3 pi times, which one do I use? I use the ones that I want on top. So if I have radians and I want degrees, I'm going to choose the one with the degrees on top. So 180 degrees divided by pi. So pi's cancel out. So I have 3 times 180 now. And 3 times 180, I don't know, but I know that 3 times 18 is 54. So I have 540 degrees. So that covers number 3 and number 4 on your unit circle section. And now starts your number 5 through 10. Now I can't stress this enough. You need to have this stuff memorized for numbers 5 through 10. But I'm going to show you how to do that, okay? So number 5 through 10 is asking you to find the exact value of each trigonometric function, okay? So this is finding exact value. And if you're not in my class, this is how I abbreviate functions. All right. First thing first, we're going to sketch out a unit circle. Here's my not so pretty circle. It's okay. All right, here it is. We only care about quadrant 1. Don't even worry about quadrant 2. So in my class, we're starting to become a little dependent on the entire unit circle. Don't be. You know the entire unit circle if you know quadrant 1. And if you know quadrant 1, you know the entire unit circle. So quadrant 1, we're just going to develop it. Now, what we're mostly interested in are our x and y coordinates, which are also your sine and cosine values. So remember, your x, comma, y is your location point for each triangle that has the hypotenuse equal to 1. So your x is your sine, excuse me, your x is your cosine, your y is your sine. Okay, now let's fill only quadrant 1 in. So here's, let's not do 0, let's do 360 degrees, 2 pi. This is, what is this? 30 degrees, 45. Make sure you have degrees in here. 60 degrees, 90. Then you have pi 6, pi 4th. I just realized you can't see that. I'm writing really small. I'm not sure why. I have plenty of space. Pi 6th, pi 4th, pi 3rd. This is pi halves. And then we're gonna, again, like I said, these are our most important things. Now, the easiest one you need to know, because it's the same for your x and y, is your root 2 over 2. Now, if you're in my class, you've heard the next thing I'm going to say, but if you're not in my class, the way that I remember my sine and cosine, let me back up how I remember my cosine and sine for the 45 degrees or the pi 4ths angle measure is, I think of Andy from The Office. So you know how Andy from The Office says root of 2, right? Root the 2, 2, root the 2, 2. That's how I remember it. Just a math humor for you. Okay, now the other one here, we're going to say root 3 over 2 and 1/2. And then I'm going to say 1/2 root 3 over 2. Now do not, I repeat, do not take the time to fill all the rest of the stuff out. You were tested, if you were in my class, you were tested on the entire unit circle. One time, that's it. I will not ask you to memorize the entire unit circle ever again. All you need to know is quadrant 1. If you know quadrant 1, you're done. Now, in a separate video, I'm going to show you how to memorize these. And by memorize, I'm going to ask you to derive these using your left hand. I'm sure you've seen other YouTube videos on it, but I'm going to do my take on it. But easiest way is just to memorize. Just memorize these values, okay? So let's get started. I will, for this section, use the exact values for the quiz. So I'm looking at your quiz, and I'm going to be using those exact values just as examples, but also because I want you guys to know what the true answers of these are. Again, this is what I'm using. So let's start with number 5. Number 5 is asking for the exact value of tangent of negative 1035, so 1035 degrees. Now, before you freak out, don't do it. Don't do it. Easiest way, and I'm going to be writing tricks and I don't want to call them tricks. They're just helpful tips. How about that? Helpful tips for you guys to be successful in solving these. Okay, first thing first, you notice they have a degree, and you have a very large degree. It's in the thousands. So we want to undo things. Before we continue, I'm going to go back to my mini unit circle, and I'm going to kind of fill in a few little extra details that I have not. So for example, I'm going to fill in, this is 360, which I already have, but I know that 360 and one more rotation or one more period will give me 720, and one more will give me 1080. And I'm going to do the same thing. I know this is 180, and 180 plus 360 is 540, plus 360 is 900. Okay, so obviously this is negative. Negative tells you direction. And the direction is clockwise. So when you're starting, you're going to go towards negative y, not your positive y. This right here is your angle measure. So we're going to try to do a reference angle or a coterminal angle. Okay, so a coterminal angle will get you closest to something more manageable. And again, we want that degree to be between 0 and 90 degrees. So we want a value of 60, 45, or 30. That's our goal. That's our objective. So I'm going to say 1035 minus 360 minus 360 minus 360. And I already have 315. So let me actually back up. Since it's negative, I'm going to say negative 1035 plus 360 plus 360 plus 360, and I get 45 degrees. So now my coterminal angle is at 45 degrees. So here's my hint number 1. Now this came from another teacher on our campus, and that's not something I knew. So I learned this from her, so she deserves all of the credit. But if your angle measure ends in a 5, your reference angle will always be 45 degrees. Let me change that, or not change it, let me move it over. So again, if your angle measure ends in a 5, it will always be a reference angle of 45 degrees. So technically we didn't have to do any calculation here. It ends with a 5, it will always be a 45. Okay, now remember how I said this negative is direction? So you still need to know how many rotations, periods, how many times around you went. So I'm going to take my negative 1035 and I added 360 to it twice and then thrice, and I'll show you. And let's say I got negative 315. And then I went one more time to get a positive angle. I wanted that positive because in quadrant 1 it's only positive. So 360 one more time. And that gave me 45 degrees. So I went around 1, twice, thrice. So then I'm here. I'm going to draw this out for you. So negative means we're going towards the negative y side. So I'm going once, that's 360 in the negative direction. Twice, 360 in the negative direction. Thrice, 360 in the negative direction. Hold on. 1, 2, 3. And let me back up a little bit. So do you see how I have this negative 315? Negative 315 is going to be right here. Now this right here, this 360 adding one more time, is me trying to find that coterminal angle, our reference angle. So this section right here is me saying how much more do I need to complete the cycle. So then here's my reference angle. We haven't gone through reference angle in this video, but a reference angle is positive, acute, and from the x-axis. So I'm saying what's my reference angle here? And this is a positive 45 degrees. And this is important. You need to do these little circles here and find out what quadrant your original angle lies in. Now, this is where we do all students take calculus. So in quadrant 1, all of your trig functions are positive. In quadrant 2, only your sine functions are positive. In quadrant 3, only your tangent functions are positive. In quadrant 4, only your cosine are positive. So again, now that we know our reference angle is 45, I'm going to bring that down here. So I have tangent of 45 degrees. Well, I don't know what tangent of 45 degrees is, but I do know that tangent is sine over cosine. So I'm going to do sine of 45 degrees and cosine of 45 degrees. And again, we should have these stuff memorized, but sine of 45, cosine of 45 is Mr. Andy here, root the 2. Same thing on top, same thing on the bottom. This is equal to 1. It is in quadrant 1, so everything is positive in quadrant 1. So tangent of negative 1035 degrees is 1. Okay, let's try another one. Let's try number 6. Number 6 says same directions, but this time they're trying to get us to evaluate sine of negative 330. Again, negative tells you direction. 330 is your angle measure. Okay, here it is. This is where I asked you to do these sections. So 360, 720, 1080, 180, 240, 900. We're going to ask ourselves, so down here, we're going to ask ourselves, question, 330 is the closest to what value? And when I'm asking that, we're asking ourselves these values. They're 360 degrees, 720 degrees, 1080 degrees, or 180, 540, 900. So which one is it the closest? 330 is the closest to 360. And then question number 2, by how much, or let's do how much is missing. And how much is missing? Missing is, we got 330, we need 360, so 30 degrees is missing. Therefore, our reference angle is 30 degrees. And how did I do that? I did that kind of quickly in my head. Ooh. Let's be careful on that. Okay, negative direction. I'm here. Going around. 330 is here-ish. So how much is missing for a complete period? And that is 30 degrees that's missing. Oh, you can't see that, I'm sorry. So 30 degrees is missing. This here is negative 330 degrees. What I did is I started at my initial rate and I ended at my terminal rate. Then I asked myself how much is missing to complete that cycle, and that's 30 degrees that's missing to complete that cycle. So I have 30 degrees as my reference angle. So now I'm saying sine of 30 degrees is, what is sine of 30? So we're looking back up here. Sine of 30, this is our cosine, this is our sine, which is 1/2. Now we're looking what quadrant our original angle is in. So all students take calculus. It is in quadrant 1, therefore our answer is positive. So sine of negative 330 is positive 1/2. Okay, let's do one more example. Let's do something with the angle being in radians. So let's do number 10. I'm going to skip around a little bit. Number 10. All right, let's continue with number 10. And number 10 is asking us for cosine of negative 14 pi thirds. So just like we did with our degrees, we're going to do exactly the same thing with our radians. So over here, I know that 1 full rotation is 2 pi, 2 full rotations is 4 pi, 3 periods is 6 pi, and on this side, I know I have a pi, 3 pi, 5 pi, and so forth. You can continue doing as many as you need. So I'm going to ask myself what 14 pi thirds is closest to. So I know I have a 3 in my denominator, so I'm thinking fractions. So I'm going to put in a thinking bubble here. Let me shift this off to the side so that way it can be a thinking bubble. Let me zoom this out just a little bit. Thinking bubble. So I'm thinking 14 pi thirds is really close to either 12 pi thirds or 15 pi thirds. Which one is closer? I want to say that this one's closer, but we're going to overshoot, and that's okay. So 15 pi thirds would be 5 pi. So we're going to be super close to our 5 pi. Now we're going in the negative direction, so we're going this direction here. So you want to be careful of kind of the distance, because this tells you the distance, your angle measure, this tells you the direction. So we know we're going to end up somewhere pretty close to 5 pi. So I'm going to ask you a question. How much will we overshoot if we go to 15 pi thirds? How much too many will we be there? So if we go all the way to 15 pi, we're overshooting by how much? By pi thirds. Do you see that? Because 14 pi thirds plus, you can't see that, let me move that, plus pi thirds would be 15 pi thirds. 14 plus 1, that's 15 pi thirds. So we would be overshooting by 1 pi thirds. So that's going to be your reference angle. So let's find out where this 14 pi thirds. So we know it's going to be in the negative direction. And we're going to go, how many full rotations? Well, we're going to get super close to 5 pi. So, and 5 pi is, well, here's 2 pi. Here's 4 pi. Again, in the negative direction. And here's 5 pi almost. Again, we don't want to get to 5 pi because we're overshooting. We want to get somewhere close. And then we said, what's the gap? The gap would be pi thirds. So this gap right here, this reference angle off of the x-axis to the terminal ray is pi thirds distance. So now we're going to say the cosine of pi thirds is what? And again, you should have these memorized. If you don't, go ahead and keep referencing your unit circle. But again, you should have these memorized. So cosine of pi thirds, you're looking for pi thirds. Pi thirds is here. Cosine is your x value, so we're looking at 1/2. So now we need to identify the quadrant our original angle is in. So all students take calculus. So in quadrant 3, the only thing that would be positive is tangent. We don't have tangent, we have cosine. So therefore, our answer would be negative. All right, guys, I'm going to pause the video here. Hopefully that answered some of your questions. If you're still confused, definitely continue watching. I'm going to go over a few other things in my next video. Again, if you have friends, family that are in any sort of integrated math 2, algebra 2, integrated math 3, pre-calculus class, go ahead and share our videos with them. I greatly appreciate it. Like and subscribe. Thank you again for watching, and I'll see you next time.